Okay, ellipses. So your ellipses have some primary properties that you're going to be looking at. You need to know the focus, the center, the major axis, the minor axis, and the vertices. So you'll notice these have a good label of what all of those components mean. So you have your center, right? It's going to be the center of the ellipse. Okay. Then you have a major axis and a minor axis. The major axis is going to be whichever one is longer. So notice in a horizontal ellipse, it's called horizontal because it's longer horizontally than it is this way. Okay, so that's why this axis is the major axis, the horizontal one. Okay, in the vertical ellipse, the vertical axis is the longer one, so that one's the major and this one is the minor. And then you have your vertices, which is where your ellipse is intersecting with those axes. All right, so you have a vertex here and here, here and here, and then notice your major axis is always the A. So if it's horizontal, the values for A are going to be found on the horizontal axis, the major axis, because that's the one that's bigger. And then on the vertical, your major axis again is the A, but it's vertical this time. Okay, so A becomes before B in the alphabet. Okay, so you're going to associate that with the major axis, the bigger one, it's going to come first. Okay. And then you have your formulas for your ellipse. So you want to know whether it's horizontal or vertical. And does it have a center at 0, 0, or is there some other center point? And then you will have the formulas that you need for the vertices, the co-vertices, your focus, your major axis, and your minor axis. Okay. So let's try writing an equation. Writing an equation of the ellipse. What is an equation in standard form of an ellipse centered at the origin? So I'm just looking at this side here. With a vertex of -6, 0 and a co-vertex of 0, 3. So if I compare my vertex and my co-vertex, right? The bigger value is going to be my major axis, and the other one is going to be minor. So 6 is in the x position, so that means that our major axis is on the x-axis. So this ellipse is horizontal. So its center is at 0, 0. It has vertices at -6 and 6 for the x, and 3 and -3 for the y. This is our major axis. This is our minor. Okay, so that means that A is 6. And then B is our major axis. Vertices is, if it's horizontal, the plus or minus is A is in the x position, and then your co-vertices is B. Okay, so B is 3. Okay. What else does it want me to find? Wants me to know the equation. So I just need A and B for the equation. So we have x squared over a squared plus y squared over b squared equals 1. A squared is 36. A squared is 36. B squared, 3 squared is 9. So that's our equation. Finding the foci. What are the foci of the ellipse with the equation 25x squared plus 9y squared equals 225. So they've given me the equation, but it doesn't match the form I need. Notice that all of these are equal to 1, and this one is not equal to 1. It's equal to 225. So your first step is to make it equal to 1. Okay, and I accomplished that by dividing everything by 225, because anything divided by itself is 1. Okay, and then I'll take the calculator to help me simplify that fraction down. 25 divided by 225, change it to a fraction. That would help if I entered the right numbers, right? Okay, so that's going to be x squared over 9, and then the 9 divided by 225 is y squared over 25 equals 1. This is a center at 0, 0. Remember that a is always the larger value. So this means that 25 is a squared and 9 is b squared. I'm matching it up. So that means that this is a vertical ellipse. Okay, so notice if it was horizontal, it would be x squared over a squared. Vertical is x squared over b squared. So since this is the smaller number, that means it's b. So that means this one's vertical. So 3 equals b. Take the square root. Square root of 9 is 3. And 5 equals a. Okay? And then to find c, we're going to use this equation. Okay? So c squared equals a squared minus b squared. So c squared is 9 minus 25. So c squared equals negative, a squared minus b squared. 25 minus 9, which is a positive 16. Take the square root, so c equals plus or minus 4. So if we're going to go back and summarize, our focus then would be, and then you have to use this, right? Pay attention which one you're using, because it's not, if you put the c first, then you're saying it's horizontal. So our foci are 0, 4, and 0, negative 4. And you got everything you need to graph it now. You've got your center at 0. We had negative 3 and 3 is our B's. 6 and 6 are our A's. And then they put the focus in red. Okay, notice that the vertical is longer. That's our major axis. That's why these are the A points, and this is our minor axis. That's why these vertices are the B points. And then it's longer vertically, so it's a vertical ellipse. Okay, well, some questions for you to try. Number 3, a room with an elliptical ceiling called an ellipsoid, since it is 3-dimensional, forms a whispering gallery. I don't know if you've ever visited anywhere that had these. Thanks to the reflective property of the ellipse, a whispered message at one focus can be heard clearly by someone standing across the room at the other focus. The elliptical ceiling has a major axis of 120 feet, so it's a very important piece of information. So that means that this is our A, right? So I have A and negative A, and this total distance was 120. So if I cut that exactly in half, this point would be at 60 and negative 60. So since they give us the major axis 120, that means A is 60. And the minor axis of 72 feet, so that would mean our B is half of that, which would be 36. And then to find C, again, C squared equals A squared minus B squared. 60 squared minus 36 squared. And then we'll take the square root to get the C by itself. So C, square root both sides, so C equals 48. And then to know how far apart they are, so this is how far apart are the foci, right? So same kind of thing here. If our C is 48, then that total distance is going to be 2C. So the distance is 2C, which is 96 feet apart. For this one, what is the standard form of the equation shown? They give you all your points, right? So this looks longer around horizontal. So that would mean that A is 8. Okay. And our B are these vertices. They're not labeled, but it looks like it's at 5. And C squared equals A squared minus B squared again. Oh, this is not 5. They have 2, 4, 6, 8, 2, 4. Let's not estimate on B. Let's do it mathematically. And let's color code. Make it easier for you. Okay, so again, this is the longer, this is our major axis, so this is A. Okay, they don't label B4, so we'll leave that where it is. But they have given us the C. This is our focus. So that means C equals 5. So let's calculate B instead of trying to guess. C squared equals A squared minus B squared. So 5 squared equals 8 squared minus B squared. So 25 equals 64. So we get negative 39 equals negative B squared. So 39 equals B squared, and this asked us for the equation. So this one is horizontal, yes? So we need to do x squared over a squared plus y squared over b squared equals 1. A squared was 64 because a was 8. And the b squared we just found was 39. We can get our equation.